Hello everybody.
Hi everybody, how are you doing today?
This is your video on integration by long division. This is a technique that was added in just 2016 to 2017 exam. Prior to that, you only had to know U substitution. That was the only other advanced method. Now you need U sub and long division, in addition to just the basic antiderivative rule. So to introduce the idea of long division, I have these two integrals here that I want you to think, which of these can you do already without needing long division? So think about that for a minute, and then we're going to talk about it and see which ones or one you can do already. So hopefully you realize that this one here can be done already right now. All you have to do is divide each term by x cubed. That only works when there is one term in the denominator. So then you can break it up like so, and then it would be natural log of x plus x to the negative second divided by negative 2. So that one's all set. But what about this one here? Even if well, you can't do this. That just doesn't work. You can only do that if there's one term in the denominator. Even if I try to force u sub because I see a higher power and a form of its derivative, well, I would have to make u x cubed, and then du would be 3x squared. And then I can try and do du over 3 is x squared. But the thing is, even if I try really hard to do u sub, this would be my u in the numerator, and then I'd have to put du in the denominator and then add 1 or something. It just doesn't work. Du can never be in the denominator. So the point is, you cannot do the first one right now. So this is where long division goes into play. And I want you to make a note here for long division. You only consider it when the degree in the numerator is larger than the degree in the denominator. And that's just because you can only divide with long division if the top has a larger degree than the bottom. Because this fraction really just means division, so let's divide it. So I'm just breaking away from my integral for a second here, and I'm going to do some long division. So this is some good Algebra 2 memories coming back here. And what I multiply x squared by to get x cubed is x. And then that would be x cubed plus x. And then let's go ahead and subtract. X cubed minus x cubed is gone. 0 minus x is negative x. And I can't divide x squared into x anymore, so I'm done. Now here is the deal. The way that you write this is you would say that x cubed is equal to your quotient plus your remainder over your divisor. Now, if writing a summary statement like this was really confusing to you, just look at a normal division problem. You always say that your original is equal to your quotient plus the remainder over the divisor. So back in elementary school, you would have written a summary statement like this, and now that you're in calculus, you can do a summary statement like this. And you need to write it like that so that you can rewrite your integral. Remember, the whole point of this is to rewrite our complicated integral into something simpler. So I haven't done an integral yet, or antiderivative at all yet. I'm just rewriting my integrand. Remember, this is your integrand. I'm rewriting it like this in hopes that it'll make everything a little bit easier. So now I have that. So the deal is, I know what the antiderivative of x is, but I don't really know what the antiderivative of this is. It almost looks like arctan, but arctan does not have an x in the numerator, so I definitely can't do that. And you know what this is? I have a higher power and a form of its derivative there. So guess what? This is an amazing problem because not only do you get to do long division, you also get to do u sub. This is like a 2-for-1 right here. So I have rewritten my integral as follows, and this is a check because this is easy. This is going to be x squared over 2. This right here, I have to take a little break and do some u sub on the side. So that's going to be 2x dx, and I just want x dx. So I'm going to do du over 2 is x dx, and we're almost there. Now that we've set up u sub, I'm just bringing this down here, and I'm going to go ahead and rewrite this with u sub. So in my numerator, x dx is going to be du over 2, and then u is going to be in the denominator right there. And let's write this a little bit nicer here. So I'm going to pull out the half, then I have the integral of 1 over u du, and then we can just finish off quick here. So here's my answer. Here's the antiderivative of this one. And then here's the antiderivative of this one. And then I just take my u value right here and replace it right there. So that was cool. Let's do a couple more together, and then I'll give you 2 to try. So again, my final answer is this. And don't forget the plus c because this is an indefinite integral. All right, let's take a look at this one. And, okay, let me just say something here. I said that consider it when the degree of the numerator is greater than the denominator. I guess I should say or equal to there, because right here the degrees are equal. But if you look at this, like, I don't know what the antiderivative of this is. So that's the only reason you would consider a long division. You definitely can't do u sub because they have the same power. So let's go ahead and divide. Now remember, it's x plus 1 divided by x minus 1. When the powers are the same, it's not obvious what the dividend is and what the divisor is. The top thing is always under here. Okay, so I multiply x by 1 to get x plus 1. And distribute, I get x minus 1. I subtract. These cancel. 1 minus negative 1 is 2. And that's it, because I can't multiply x by something to get 2. So I'm going to rewrite this integral as, instead of x plus 1 over x minus 1, I'm going to say 1 plus my remainder over my divisor, dx. And let's go ahead and split this up with a dx for each. And pulling my constants out, so it's real easy to look at. Oh, you know what? I meant to make this a definite integral. Hold the phone here. All right, I'm going to go from 2 to 4. And nothing is changing here. This is not like u sub where you have to translate everything here. You're just rewriting this with division. No translating needed here, which you're probably thinking, thank God. And 2 to 4. Okay, the antiderivative of 1 is x from 2 to 4 plus 2 times the antiderivative of this is natural log of x minus 1 from 2 to 4. You could have just 1 2 to 4 at the end for this whole expression, but since I already committed to 2, I'm just going to keep going with the 2 here. So that means I'm going to do 4 minus 2 plus 2 times natural log of 4 minus 1 is 3, minus natural log of 2 minus 1 is 1, natural log of 1 is 0, 4 minus 2 is 2, plus 2 natural log of 3. No plus c here because I turned this into a definite integral. Now keep in mind what this really means is this is the area under the curve. So x plus 1 over x minus 1, there's a vertical asymptote at what, 1? Yeah. And the horizontal asymptote is also at 1. So I have like some graph here. And all I'm saying is if this is 1, from 2 to 4, 2 plus natural log of 3 is this area. So don't do this and make it so abstract that you forget what's actually happening here. We're still just finding the area under the curve. That's how you can always think of your answers. Okay, I'm going to do one more here. And let's do, I really like this one here because it's a good review of some antiderivatives. So don't want to give it away. All right, now again, your degrees are equal here. It's not like it's not like the numerator is bigger than the denominator, but I can't do u sub, and I don't know what it is off the top of my head. So that's how you kind of know you have to try something else. Let's try long division and see what happens. All right, so I multiply x squared by 5 to get 5x squared. Let's distribute that thing there. 5x squared plus 5, subtract. That's gone. 0 minus 5 is negative 5. So I'm going to rewrite this integral as 5 minus 5 over x squared plus 1 dx. Don't forget the dx, and this was right here. So I'm going to break this thing up here. It's the integral of 5 dx minus 5 times the integral of 1 over x squared plus 1 dx. And I love this antiderivative because it forces you to remember your arctangents and arccotangents and all that good stuff. So the antiderivative of this is 5x minus 5 times, now this antiderivative is arctan. Now let me show you something else quick here. There's actually 2 different answers here depending on how you handle your negative. So in this one, the first time I took this negative 5 Right. Oh, God. Okay, I took that -5 right there, and I just took the whole thing out. So then this was a positive, and the antiderivative of positive is just tangent. Or you can choose just to take the 5 out and keep this negative with it, and then the antiderivative with the negative is arc cotangent. Either one just depends how you handle your negative. Okay, I'm going to give you 2 U tries. Here are the 2 problems I want you to do. I have a definite one and an indefinite one. So do these in your notes and we'll compare in class. And I have an awesome integration review sheet for the next time I see you. Bye!